have read the fundamentals of logic, mainly the propositional logic, the predicate logic, the difference between propositional and predicate logic, then the laws of logic, the laws of inference, and some examples also we have seen that how they are used for some for solving problems. Today we will see all the rules whatever we have read, that how they are actually used to represent symbolically or with logical symbols the statements of a problem and to infer something, that means to conclude or to prove, given a conclusion whether that is true or false, and in that way we can tell whether it is whether it proves a statement to be correct or false. So, first we see how the laws of inference is applied to practical problems. We have read the quantifiers last lecture, and today we will see that how these laws of inference are used for quantified statements for practical problems. Laws of inference So, the quantifiers we have read are of two types. One is the universal quantifier, we have given the name for all x, p x, that for all x is the, or I can write only the for all x the universal quantifier. If I write for all x p x, then immediately I have to mention a domain of discourse D. It means that x can take values from the set of element D. D can be a set, say D1, D2 like Dn. So, if we remember that the main difference between the propositional logic and the predicate logic, I mentioned that predicate logic mainly that involves a variable, and the variable can take any values, and this is some specific values it take. That means, when x can take a value d1, then I can write p d1. So, this is when I give this p d1, then it is called the some the proposition, because P x is the proposition. So, the proposition with a specific value of x, say here x equal to d1. So, this is called the specification. So, for all x p x, if I write p d1, this is called the universal specification or universal instantiation. Universal instantiation. This is, I write that for all x p x, if I replace this thing by I replace p d1, this I replace as p d1. Okay. Similarly, if I use the for existential quantifier, there exists x, which is my existential quantifier, then there exists x p x, domain of discourse I take the same thing, the d, then I can write that it is p d1. Similarly, I can write this is p d1 and it is written as the existential instantiation. So, very simply I can tell that both p d1 when there exists x p x or p d1 for all x p x, that means for a specific value of x, that is why it is called specification. I can tell this is also existential specification, that one for a specific value of x, that what will be the proposition. Now, in our real life problem, that most of the cases that it will take some instances, that means that variable can take a value for a particular problem. We see with some example this thing. So, we take one example, very simple example. We take that everyone loves to join either Microsoft or Google. Amit doesn't love Microsoft. So, Amit loves Google. So, we have to check whether this inference is correct or not, or whether this statement is correct or not. Now, we apply the proposition, or we see that from predicate logic, or the how we can use the laws of inference for this quantified statement. So, first we see we assume some proposition. So, proposition I take that mx is X loves Microsoft. And Gx is X loves Google. So, everyone loves to join either Microsoft or Google. So, for everyone means for all x. So, what is my, these are my hypothesis. So, what is that for all x everyone is, that means everyone, that for all x hypothesis is mx or gx. Now, Amit does not love Microsoft. So, if someone does not love Microsoft, if it is general variable for x, then x loves Microsoft. So, x does not love Microsoft, that I can write as negation mx. Now, x can take the value that if I put x is Amit, because it is for everyone that. So, if x is Amit, so this is something called the instantiation. That means, if I write that negation ma m negation m Amit. So, this is something is called that instantiation or specification. This is something called instantiation or specification. Now, if I replace this here, that x is Amit with this instantiation, then we can get that mx m a m Amit or g Amit. See, here we note that whenever it is instantiated by some value, specific value, then we omit this quantifier, that here it is a universal quantifier that we have replaced. So, it is called that universal instantiation. It is universal instantiation. Now, I have negation m Amit and m Amit or g Amit. So, I can write with from this again I write this one is okay. If I give some numbering, say this is my 1 and this is 2, that. So, from 1 and 2 we can write that it is M-omith. M-omith, negation M-omith. So, it is from okay, I write from 1 and 2 we can write that it is G-omith. And this rule of inference, it is called the disjunctive syllogism. So, this is one rule of inference. This is my rule of inference. One rule of inference that if we apply for 1 and 2, for 1 and 2, then we get that it is, that means G-omith, that means Omith loves Google. So, we can tell that okay, this is Omith, the conclusion that Omith loves Google. So, first we have taken the propositional function, then actually the predicate, then the variable takes what particular value what just now we have defined, that this is instantiation or some specification, and when specification if we put, then we omit the notation of that universal quantifier, we write, and then only we can apply the rule of inference. From there we get the, we check whether my conclusion is correct, that means, or inference is correct. That means, given hypothesis, these are my hypothesis and this the conclusion is true. Okay. So, now we see another example. Say a student in the discrete structure class has not read the book. And everyone in discrete structure class has passed the first class test. So, these imply that someone who passed first class test has not read the book. So, whether our conclusion is correct or not, that we have to check. So, first thing is that we consider some proposition. So, let C x is the student is in the class. Discrete structure. X is in the discrete structure class. X is in the class. X is in discrete structure class. Then Bx, that X has read the book. And Px is the proposition that tells that X has passed the first class test on DS. So, now what are the hypotheses given? So, the hypotheses are a student in the discrete structure class has not read the book. So, there exists X, a student. So, someone, there exists X that in the discrete structure class C x, and he has not read the book. So, C x and not read the book. So, it is negation B x. This is one hypothesis. And then everyone in DS class has passed the first class test. Everyone. So, for all x, for all, that means everyone that has passed the first class test, that means for all x, P x is true. And then we have to check that whether someone who passed first class test has not read them. That means, with the conclusion should be okay. That someone who passed first class test has not read the book. First class test means that it is P x, that means there exists x P x, and who has not read the book, that means negation B x. Now, we have to check whether given this hypothesis, whether the conclusion is true or false. Now, we apply the rules of inference and for this quantified statement. Now, there is some procedure to do this thing. So, the procedure is that we have to write for the solution, we have to write this solution we write the steps and the reason. So, we start with the hypothesis, there exists x Cx and negation Bx, and this is the hypothesis or premise. So, we write that this is a given premise. Now, we take one existential instantiation, that means x takes a value say a, that means I give C A and negation B A. So, this is existential instantiation on step 1. Now, we note that we have omitted that whenever we have done this instantiation, we omit this quantifier, this existential quantifier. Now, we can actually apply the laws of inference. So, we can take that only C A, which is nothing but the simplification. Because if it is a conjunction, then we can write any one of these of the proposition. Then we have another hypothesis that for all x, C x implies P x. This was a premise. That means if he is in discrete structure class, he has passed the class test. Now, again universal instantiation if we do, then this is C A implies P A. I write that universal instantiation on 4. Now, all are passed. So, I can write that it is P A, or even I can apply some rule. It is actually modus ponens. The rule of inference is the modus ponens on C A, and C A implies P A on 3 and 5. Now, I have also I can from 2, I can also write it is 2 also tells it is negation B A is also true. Again this is simplification because these are conjunction. So, again this is simplification of 2, this is also simplification of 2. So, now I can write that P A and negation B A. This is conjunction of of 6 and 7. So, now I can write that there exists x P x and negation B x, which is the existential generalization, because in step 8 it was a instance for x equal to a is one instance, and then we can generalize and we can tell that this is existential generalization. And so, it is true, that means for all x that someone who there exists some x is there exists some x that who has passed, but not read the book. So, if we can summarize that thing, that rules of inference for quantified statements, we write whatever we have read. If we just do the summary, that rule of inference for universal quantifier and the existential quantifier. So, these are the rule of inference, and we give the name. One for universal quantifier, we can write for all x p x. So, we can tell p d if d is in the domain of discourse capital D, and we call this is the universal instantiation. Second one, that reverse, that means if P d for every d in D, for all D, then this means for all x p x. This is universal generalization. Now, the same thing we can write for there exists x p x some p d if for some d in D, the domain of discourse. Which is existential instantiation. On the reverse, that P D for some D in D there exists x p x, which is existential generalization. So, whenever the rule of inference will apply, we have to remember these two quantification, that is the universal quantification and the existential quantification. And the one point we must remember, this is very important, that whenever we will use some laws of inference, that it must be the some quantified statement. That means, that it must be that some instantiation must be done before that. Like here in step 2 we have done that x equal to a, that means there is no quantifier here, there exists x or forward x, then only we can apply. So, this is something we must maintain, that whenever we will be using laws of inference to solve some problem, that we have to write in these steps, and the whatever the reasons, that means the which laws of inference we have applied, that we must mention here, and this is some convention we must follow. So, with this we finish the lecture of the foundations of logic, and how the logic rules, the mainly the laws of inference, the laws of logic, the negation, how to find negation, the De Morgan's rule, they can be applied on the propagation.